nowadays we associate, or when we think of general and special relativity, we think of Einstein, which makes sense since his contributions to those fields were the most important. But if it weren't for a lot of the scientists before him, he may have never had a chance to have those thoughts and ideas that he did. So the history of general and special relativity kind of begins in 1865 with Scottish physicist James Clerk Maxwell, who demonstrated a couple things. First off, he demonstrated that light is a wave with both electrical and magnetic components. And secondly, he established the speed of light, which is 186,000 miles per second. And back then, there were a lot of misconceptions about light and, what would become general and special relativity. So the first one of those was that they believed that light had to move through a medium, which we now know isn't true. Light can move through a vacuum. And they called this medium that they thought light had to move through, they called it the ether. And later, physicist A. Michelson and chemist Edward Morley both tried to calculate how Earth's motion through this ether would affect the speed of light and how it's measured. But they found that the speed of light is the same no matter what Earth's motion is.
Hello, I'm Hunter, and I'm supposed to tell you about our physical model. However, I'm going to talk about trains instead. Now, trains are classified as locomotives, which means that they are engine-powered vehicles. Now, trains usually run over tracks. However, some really cool trains run over monorails, which reduce friction. Now, reducing friction is important because it can make the train go really fast. A good example of this would be the fastest train in the world, located in Tokyo, Japan, which is the L0 series maglev. Now, this train can go upwards of 22,500 miles per second. Now, I want you guys to close your eyes and picture this. I want you to think of a train that can go 8.3 times the speed of the Japanese maglev train. I know. I guess it's pretty cool. Well, now I want you to imagine that train, same train, going towards a train station where trains like to go. Now, as it is about to reach the train station, boom, gets struck by lightning. Luckily, nobody was hurt, but the train conductor, as well as someone at the train station, saw the lightning bolt hit the train. Now I want you guys to think about a few questions. Would they see the lightning bolt at the same time or at different times? Would the person at the train stop be witnessing the lightning bolt slower because they're at the train stop, and would the person at the train be witnessing the light bolt move faster because the train is moving fast? These are all great questions for a physicist or Arvind.
Clocks on airplanes and satellites travel at a different speed than those on Earth. We are all traveling in time at approximately the same speed, 1 second per second. When we think of the phrase time travel, we are usually thinking of traveling faster than 1 second per second. Theory says that time and space are actually linked together. Nothing can travel faster than the speed of light, which is 186,000 miles per second. So according to this theory, the faster you travel, the slower you experience time. So back to the airplanes and satellites, how they travel at a different time, because when you go higher up, gravity works different. So if you had a stopwatch and you're on Earth, started the stopwatch and the flight on the plane had a stopwatch and it flew and it went and you started at the same time, when it's in the air and it loops all around the Earth and comes back to where you are, time on that airplane will be slower than when you started. Even though you started at the same time, it will be slower on the plane.
Thank you for watching.